Okay, so in this video, we'll be covering internal to part B, which is similarity and dissimilarity. Our first question says, briefly outline how to compute dissimilarity between complaint profiles, nominal attributes, for example, jurisdiction, police station, offense category, asymmetric binary attributes, numeric attributes, and term frequency vectors. Right. So let's discuss about it. We have first is nominal attributes. Here, uh, there is no intrinsic ordering about the categorical feature. For example, this is one of the nominal attribute where all the feature mean there is no order in the features, right? So let's look at the question again. Now we for those attributes we have to compute the dissimilarity. So dissimilarity for attributes are or these types of attributes are often find out using dissimilarity matrix. So we will construct dissimilarity matrix with the formula d of I and j, that is p minus m upon p, where m is the number of matches and p is the number of attribute describing object. So like this, we will cover a dissimilarity matrix where this row is means dissimilarity between second object and first object. This means dissimilarity between third object and first object. This means dissimilarity between fourth object and first object, and so on. We will construct a matrix of the four. We have four records, so we'll have a matrix of 4 by 4. Right now, so as we know that for first one, the between first similarity between first and first is zero. Dissimilarity between first and first is zero. That means the records are similar, right? Similarly, we calculate dissimilarity for all these, and diagonals will be 0 0 0 as all record are similar to itself, right? So we will calculate, and after calculating we find that 1, that is CA, and 4, that is code A and code A complaints. We got two code A complaints. So first data object and fourth data object are highly similar. Highly similar means the value 0, that is 4 by 1, right? Similarly, we calculate this, we got 1, that is highly dissimilar. Similarly, we calculate for all the elements and we get the dissimilarity matrix, right? Now let's discuss about asymmetric binary attributes. Binary means there would be two outcome. Asymmetric means there would two states are not that equally important, and we say that agreement of two ones is greater than two zero. Means having two ones would create a greater impact than having two zeros. For example, there is a case where we are representing theft and criminal case, theft case and criminal case. Theft case, if it is a theft case, it is 1. If it is a criminal case, it is 2, and so on. So based on that, if it is both theft case and criminal case, it have two ones, right? So the importance of two ones is more than having none of them, right? So similarly, asymmetric binary attributes, here we calculate the dissimilarity like this. Let me remove this to make a clear understanding. Yeah, here we calculate this with the formula r plus s upon q plus r plus s. Similarly, if I want to create a formula for similarity, it will be nothing but 1 minus dissimilarity of ij. That is, if I subtract this whole with 1, I will get this formula. It is often known as Jaccard coefficient of dissimilarity, right? So this is an important one. Now let's discuss about numerical attributes. In numerical attributes, we can, for computing the dissimilarity, we can use distance measures like Manhattan distance, Euclidean distance, Minkowski distance, which is general version, and supremum distance for n equal to infinity or for k equal to infinity, right? The fourth one attribute is term frequency vector. So, what is term frequency vector? We represent a document in the thousand. A document represents thousand of attributes, right? And each recording frequency of keywords. So we create a table where for document one we keep only important words, right? For let's say good report and bad report. So in document one we have two occurrence of good and five occurrence of bad. Similarly, in document 2, we have 3 occurrence of good and 8 occurrence of bad. Based on that, we compute the similarity score between the documents, right? This is known as term frequency or inverse document frequency vector, where we represented this data in the form of vector. For example, we have represented it in the form of vector, right? So, yeah, now let's move on to the question 2. Term frequency vectors can also be used for keywords. Like if I found a keyword like stealing, so I can map with the keyword, I can map with the section IPC or BNS section with it. So we are storing these keywords in the form of vectors in each complaint or in each document, and this will help in section mapping, right? So now let's move on to the question 2. Question 2 says we are given tuple representing the incident duration and witness present, if the witness are present, or incident duration, right? Now we have to compute the distances, right? So let's see the distances. First of all, see the distances formula. We have Euclidean distance with under root of x2 minus x1 upon y2 minus y1. Then there is no under root in Manhattan distance. We have mod of x2 minus x1 upon plus mod of y2 minus y1. Then we have Minkowski distance, which is a general version in which we have a under root of power p, and p decides the distance measured, right? Then we have supremum distance, which is for n equal to infinity, right? Which is for n equal to infinity, and it is used as max. It uses a max function. Now let's calculate the distance for tuple. We first calculate the Euclidean distance. That is, we take 20 minus 22 ka square, then 0 minus 1 ka square, 36 minus 42 ka square, and 8 minus 10 ka square. And putting these values, we get root 45, which gives us value this. Similarly, we calculate supremum distance, that is max of x2 minus x1, y2 minus y1, z2 minus z1, and k2 minus k1, right? We get the value as 6. Similarly, we calculate with the formula Minkowski distance. We have taken k equal to 2, which will give same outcome as uh, Euclidean distance, right? Then we do it with Manhattan distance. We calculate Manhattan distance, that will be 11, right? So we have calculated distance. Now let's see question 3. The median evidence impact score is often a robust indicator for triage, routing to fast track. Yeah, for massive complaint dataset, propose median approximation methods like this, analyze time space complexity, and suggest heuristics to balance accuracy versus efficiency. Yeah, so let's discuss some median approximation techniques. So first technique is GK quantile summary. In GK quantile summary, we keep small ordered summary of sample values with error bound on their ranks. And for each incoming score, we insert it into a summary and use merge entry or merge data structures, right? So here space complexity boils down to 1 upon error upon log of error into n, where E is the error that can be reducible or non-reducible, right? Then we have T digest, in which we maintain a centroid or cluster between the nearby values, each with a count, right? And there are more centroids in the tail, less in the center, and originally it is designed for high accuracy percentage. Space complexity is very least, like it will be only big of k, and it is good for practical use. Then we have reservoir sampling, in which we keep a uniform random sample of size k from a huge stream. Now, what we do is we take the first k items in the reservoir, and for the ith new item, where I is greater than k, we include it with the probability. We calculate the probability of that event or that new item, which is k by I, and if chosen, replace the random existing sample, and if it is the value is chosen, we replace it with the random sample, right? Here the time complexity is big of k log k, and space complexity is big of k, which is as good as T digest, right? Now uh, it is used where accuracy improves as k grows, right? So, and it is a simple and fast. Yeah, reservoir sampling is widely used because of its simpleness and its fast operation. Then we will see heuristics, how to balance accuracy versus efficiency. Here, first thing we need for before sampling, we need to fix a error budget, right? We need to pick an error budget and which your dataset can handle. And according to that error budget, we will decide the median approximation method, whether we should use t-digest or a reservoir sampling or GK quintile, right? Then we can integrate streaming and mergeable structures which perform real-time operations on the data, reduces the complexity, and we can also separate by segments, right? We can separate the we can distribute the complaints in various segments and generate different summary for complaint types, regions, section, etc. And after doing which the result is, it increases the incredibility of the data set, right? So it will be easier to understand what complaints are should be mapped to what type of section, right? So this is question 3. These are all generally done for large data set where median is a robust measure. Now we have question 4. We are given a sample dataset, responsiveness of accused, support gain due to infrastructure misuse. Now, first we have to rank them with different distance measure. We are also given a query point and we are given complaint and file 1 and file 2. We have to first rank them on based on query point and then normalize each complaint vector to unit length and recompute, right? So let's do it. Here is the question. I have created a complaint into this vectors. Now this is our query point. Now according to that, we will compute distances. First is Euclidean distance. That is nothing but x2 minus x1 square plus y2 minus y1 square whole root. Now first we will calculate 1.4, that is query point, 1.6, that is query point, and 1.5, 1.7 we have put it here. Now after calculating this value, we will get 0.1414 as distance. Similarly, we calculate for complaint 2, complaint 3, complaint 4 and complaint 5. Now based on distance, we check that the distance should be, if the distance is high, it is most dissimilar. If the distance is low, it is similar. So based on that, we have as we can see, C2 have highest distance, then C5 has highest distance. So C2 is most dissimilar, then C5 is most dissimilar. Similarly, C1 is most similar, right? Then we have from the query point. Then we have Manhattan distance. We use this formula to calculate this. We'll get this value. As we can see that the C2 complaint is most dissimilar, and then we have C5 complaint that is most similar and the dissimilar, and then the similar one is D1. So based on that, we have ranked them. As we know that the distance of C2 is more, that means it is more dissimilar. Now we will find supremum distance, that is we calculate different max of x2 minus x1 comma max of y2 minus y1. Based on that, we calculate distances. We get these distances and we rank them according to that. As we can see, 1 and 2 and and 1 and 2 and let me see, 3 and 4 and 2 or 5. 2 and 5 and 1 and 2. These all get equal distances. So see, C2 and C5, C3 and C4 are equal, and then most similar is C1. Then we can calculate cosine similarity as it is represented in term frequency vectors. So this is the formula. We first calculate for the point C1. Here we calculate under magnitude of C1, which is 1.5 square plus 1.7 square. This we get this value. Then we calculate the mod for the query point. Then we put this in the formula. Here this is the dot product, and we get this value as this. Here similarity score, if the similarity score is close to 1 or 1, it means they are most similar. If it is 0 or close to 0, it means they are dissimilar. So we get these values, and based on that we know that it is the closer to 1. So C1 is the most similar. Similarly, if you see C5 and C2, C2 is having least dissimilar score, so C2 and C5 are least very dissimilar to the query point. Now we will normalize the vectors to unit length and then recompute the distance. So this is the formula for normalizing. Here we are normalizing each of them based on their magnitudes. On normalizing, we get those points, And now we will again recompute this value with the new query point. So we will get these distances. Now again, based on these distances, we will rank them. So C5 is again the most dissimilar complaint and C1 is the most similar complaint. So based on that, we solve this question. I hope you found it helpful. Thank you.